And let's move on to Iterators 4. Factorial. To do, complete this function to return the factorial of num. Do not use early returns, using a return keyword explicitly. Try not to use imperative style loops or additional variables. And for extra challenge, don't use recursion. Well, I mean, the immediate way I can think of doing it, it doesn't require any of those. But maybe what we should do is work through these guys first and then show how it would be done simply with the iterator using the dot product. Not the dot product, but the product collector on an iterator. So we can do imperative style loops. It's saying don't do this in additional variables. We can do it, let's do it that way really quickly. Right? For I in 1.num, result times equals I, and return result. Right? Oh, because it's taking in a U8 and returning U64. How annoying is that? As U64. And this has to be mutable. And I messed up. How did I mess that up? Oh yeah, Mizzard points out that the range is not inclusive. So it has to be inclusive. Thank you. So that's using imperative style loop and additional variables. The next thing is saying don't use recursion. Well, let's do recursion really quickly. So this would be num as U64 times factorial of num minus 1 if num is greater than 1, else num as U64, right? So that would be the recursive way to do it, and that failed. Oh, if num equals 0, then it's 1. Else, right? Yeah, so that would be the recursive way to do it. The other way, without using any of these guys and just using the imperative style, or rather just using the in iterator, which is what we're trying to do, we can just say 0 dot dot equals num as U64 product. Not 0, 1. Right, and that works. It's a little awkward with the if statement in here. It'd be nice if there were a we got it says functional style. Thank you. It's functional style. I think that's where we go with that. I mean, it's using an iterator. It's generating this as an iterator, right? This is an inclusive range. I can't really show the I can show the type. Let R equal. So if I do that, it's a range inclusive of a U64 type, and then we use the iterator, the product function on iterator, to consume that range and multiply all the numbers in it. Right? Oh, right. Like that. And I'm going to put it all the way back. There. Okay. That's Iterators 4. What's next? Iterators 5. Let's define a simple model to track Rustlings exercise progress. Progress will be modeled using a hash map. The name of the exercise is the key, and the progress is the value. Two counting functions were created to count the number of exercises with a given progress. Recreate this counting functionality using iterators. Try not to use imperative loops for a while. All right, so we have count 4, which is the thing that is supposed to be doing the thing. So this is just doing this. So I think, okay, so we have two different to-dos. Count iterator and count collection iterator. All right, so we're just basically implementing this as an iterator. We're just counting up all the values that match a particular value. So we can say we have the map, and we're going to iterate on them. We want the values, right? And we want to filter on the value to see if v is equal to value. Now, we might have to change this guy because that's ampersand, ampersand progress, and this is regular progress. So we can put an ampersand here and a star here rather than putting 2 stars on v. Right? And then we just do a count. And that should give us the count of things that pass the filter. Let's change this to 0 so that we can get the code to compile. All right, so now we have tests passing and we still have 4 tests that are failing. And that's probably because we have to finish this guy here. So this is count collection iterator. We have a collection, which is a container, a slice of hash maps. So we can use what we just wrote. And this just looks like we're doing the count, and then we're mapping over all of the items in the collection. So, and then just counting everything up. So we can use the sum operation on that. So we could say map values. And we can map that into, let's do v again. And we're looking for, again, just for this one particular progress. So we can say count iterator on v progress, v value. And that's going to give us a bunch of counts, and we need to sum those together. Oop. Oh, it's called collection, not map. And we have to iterate over the collection to get the values. There. Still doesn't like it. Oh, that can't be dereferenced. Very good. Okay. Oh, that means we don't need to do this. Yeah, perfect. How's that? You can see it's a lot simpler than all this kind of jazz. As long as you can read this as functional style, then we're good. All right, so what's next? Box 1. We did a little bit with boxes earlier. At compile time, Rust needs to know how much space a type takes up. This becomes problematic for recursive types, where a value can have as part of itself another value of the same type. To get around the issue, we can use a box, a smart pointer used to store on the heap, which also allows us to wrap a recursive type. Recursive type we're implementing in this exercise is the cons list, a data structure frequently found in functional programming languages. Each item in a cons list contains 2 elements, the value of the current item and the next item. The last item in the value is called nil. All right, to do. Use a box in the enum definition to make the code compile. So we just need to put a box around this. All right, and then we have to do create an empty cons list. All right, so it's just list nil. And this says to do create a non-empty cons list. So this would be list cons of some value, and then list nil. That's a non-empty cons list, right? Oh, I have to put it in a box, of course. That's the whole purpose of this exercise. There we go. Gaffa says, love it, functional as much as possible. Oh, for the count iterators, yeah. Yeah, I like doing the functional style as long as it doesn't obscure the logic. There have been times in AOC where I've done it using fors and whiles, and then when I convert it to an iterator style, it's just way too nested and way too gross looking, and it makes it hard to read. But when you have like a one-liner, like we had in the previous one, that's perfect. All right, what's next? RC1. Oh, so there's no box 2? I guess there's not much to talk about with boxes, huh? RC1. In this exercise, we want to express the concept of multiple owners via the RC type. This is a model of our solar system. There is a sun type and multiple planets. The planets take ownership of the sun, indicating that they revolve around the sun. Okay. What are we doing here? What's the to-do? To-do. To-do and to-do. Okay, so we're just modifying the tests. Are they just asking us to just duplicate what we've got here, for example, in Jupiter, right? Because it's saying, okay, we've added a reference to this. So instead of doing RC new, we're going to do RC clone of sun, right? Yeah, and now this, we're down to the next one. Okay. And now what do we have? Oh, to do, we haven't dropped. Okay. Drop the Earth, drop Venus, and drop Mercury. Yeah. Okay, so that's all they're looking to do. We're not modifying code. We're just fixing the tests of the test pass. JP says, my style is that as soon as I need a multi-line block inside a map or filter or whatever, it should just be a for loop. Yeah, so once it gets a little too long, I agree that you got to switch. You got to switch it over to something that it's easier for future you to understand when you come back to it. Okay, so that's all that was. It's an RC2? No, there's an ARC1. Okay.